Hello and welcome to another video. In this video, what I'm going to do is I'm going to tell you all the graphs that you might come across in P3. Let's discuss and see what the past papers have and what else can come up. Okay, so starting with first modulus functions, you can have graphs of modulus functions in your exam as well. It's easy to draw modulus functions. The simple idea is that whenever a modulus opens up, it opens up with a plus and a minus. So you have a plus and a minus, plus 2, and you try to draw these individual lines and then keep the V-shaped graph and then erase the rest of it, and that should work. The y-intercept here is -2. The x-intercept is 2. Okay, so this graph will probably look like this. We just draw a straight line, and this will have a y-intercept of 2 and x-intercept of 2 as well. Okay, so that graph looks like this. So I'm going to keep the V and erase the rest. That is the part of the graph that I want to keep. Okay, that's going to be my final graph. I'm going to erase the rest and I'm going to say that this is the graph of y equals to modulus x minus 2. You can be asked to sketch the graph of any modulus. The simple idea is that sometimes it can be in inverted V as well if there was a negative outside the modulus. So that is something that you should be aware of, that I would have kept the inverted V in case the modulus had a negative sign outside. Modulus doesn't have a negative sign outside. The reason I have a negative here is I've removed the modulus. Okay, that's one graph. Let's see what few other graphs that I have here. So this is a typical graph, e power minus half x and 4 minus x squared. It says by sketching a suitable graph, e power minus half x and y equals to 4 minus x squared. Okay, so you should know what the graph of e power x looks like. So you should have this idea that e power x, if I was drawing simply e power x, I would have a y-intercept at 0, so e power 0 would be 1. Remember that whenever you're sketching these graphs, there are two important things to the graph. One is that the shape should be correct, and the other is that the intercept should be correct. Okay, so you have x and y, e power x should look like that. But this graph can, of course, transform, so e power minus x would be different. Now, again, if you were drawing e power minus x, the shape would be same, but the graph would be coming down like that. Okay, drawing it as accurately as possible I can. Okay, so that would be it. Okay, that would be e power minus x. E power 2x, again, e power 2x would simply mean, if you remember the transformations from AS, it simply means that the graph is going to shrink. So it's going to go rapidly up, but I have never seen on the exam where you would be asked to, sort of differentiate between something going rapidly up or not going rapidly up. The two things that are important is that the sign should be correct and the shape should be correct. So in this case, the first shape that I have is at 0, the graph is at 0, so I'm going to draw the graph like that. Let's draw it with the red. Okay, that's the graph of e power minus half x. Now it's expanded a little. I've not drawn any intercept, so you don't need to worry about the minus half. The stretching doesn't bother me. Okay, the next graph is 4 minus x squared. So this is a typical quadratic, and if you remember from your quadratic, from your AS, the turning point is important. In this case, I can simply calculate the turning point by differentiating it and saying that dy by dx equals to minus 2x, x equals to 0. So I have a turning point at 0. When I plug in 0, this is at 4. So there's a turning point at 1, 2, 3, 4. What sort of a shape am I looking at? I'm looking at a sad face curve, so it's going to look like that and look like that. Okay, has one positive root and one negative root, so that's the conclusion: positive root, negative root. Okay, so you can be asked to draw quadratic graphs, you can be asked to draw exponential graphs. We'll see more graphs as we go on along the way. Okay, let's see what this one has. This was the equation ln x equals to 1 plus 3x, and that's 3 over x. Okay, so I'm asking you to has only one root by sketching a suitable pair of graphs. So that's obvious that I need to draw the graph of y equals to ln x and 1 plus 3 over x. Now, when I'm drawing the graph of ln x, I need to know its correct shape and that it passes through 1. Okay, when I plug in, now in this case, you cannot have ln0 because ln0 is undefined. So it doesn't have a y-intercept. But does it have an x-intercept? Yes, it does have an x-intercept. It has an x-intercept at 1. Okay, so the graph looks something like this. Now, what I've seen in the past papers is that sometimes you might be asked to draw ln2x. Okay, again, that doesn't matter. It's just a shrink. What you just need to know is that this x value would transform and it would now be at half. Okay, because you get ln2 into half and then 0 and so on. Okay, you would do the same thing and you say that this is e power 0 over 2x. You don't need to know the correct x-intercepts. And if you don't know the correct intercepts, just calculate them and the y-intercepts as well. Okay, so ln x would look like this. I can also have a graph of ln x minus 1. In that case, it's going to shift 1 unit forward and look like that. So you need to know that as well. Okay, then this other graph is a reciprocal function. Now, for reciprocal functions, remember that um, does it say any limits? Okay, so 1 over x looks like this. Okay, 1 over x square looks like this. Okay, now all of these, this graph is basically transformed by 3 and 1. So 3 is a stretch. So the graph stretching doesn't really bother me again. It just looks more steeper and goes like that and comes closer to the x-axis, closer. Okay, it's right now has an asymptote at 0, so it's not touching 0. But when I try to draw the graph of 1 plus 3 over x, the entire graph will have to move 1 unit up. Okay, so it's going to move 1 unit up and look like that. Okay, and there's going to be another graph here, but it's not going to intersect the other graph that I had. Let me change the colors. The first color has to be blue. Okay, so there's only one intersection point. So I could ask you to draw the graph of any reciprocal function. Okay, moving on. I have to draw the graph of ln x plus 2. Now remember that ln has that shape, but I will have to find out its x and y intercepts. So ln x plus 2. Okay, so y equals to ln 0 plus 2 first. I'm trying to find the y-intercept. So the y-intercept is at 0.693. What about the x-intercept? X-intercept is going to be at -1, I think, because it's moving 2 units backwards. Okay, that's what I know. So my graph is going to look something like this at -1 and 0.693. So my graph is going to look something like this. That's the graph of ln x plus 2. You should also try to label the intercepts. 4 e power minus x, e power minus x looks like that. Okay, 4 e power minus x is just going to be a little bit steeper. So it's going to come down from there and then intersect that graph here. Okay, so I'm going to say one root, one intersection point or one root. So that's 4 e power minus x. I don't need to do anything else. Uh, in fact, let's just, there's one mistake here. 4 e power minus 0. So its y-intercept is going to be at 4. That's a mistake that I made. It's still going to have the same shape, and that's 4 e power minus. Okay. Then I've already drawn the modulus graph for you. Okay, let's see what this one has. It says sec x. So you need to know the graphs of sec x, cosec x, and cot x. Okay, those three are there in a separate video on trigonometry. Just make sure that you know this. I'm just going to draw a bit of it here. It says it has exactly one root. So what are the two graphs that I'm trying to draw? I'm trying to draw sec x and 2 minus half x. Okay, sec x is 1 over cos x. Okay, so I just need to draw it up till pi over 2. So I'm just going to label pi over 2 here. Okay, let's make it sufficiently large enough for me to draw a diagram. Okay, now this becomes a little challenging. Sec x is 1 over cos x. Cos x used to look like that. Okay, so sec x will have an asymptote here. Okay, sec x will have an asymptote here, and okay, that is what the graph of, no, not from 0, it's from 1. Okay, now the real challenge is drawing the other graph on the same axis, 2 minus half x. What sort of a graph do I have? It's a line, it's a straight line. So I'll need the y-intercept and the x-intercept. I can see that the y-intercept is 2 and it should be a downward sloping line. But where do I have the other end point? I see that the coordinate axis is marked in terms of pi. So why don't I also do this? That I go on and calculate this in terms of pi. Let's see what we get. 2 minus pi over 4. I get 1.215. 1.215. So this point has to be somewhere here. So I'm going to take this and draw a straight line through these 2 points and nothing else. Okay, and that is what the graph of 2 minus half x and sec x should look on the same graph. You should take the endpoints that are there available to you. Don't take values of x as 1, 2, 3. Why? Because your axis is labeled as pi over 2 pi and so on. Okay. Okay. Then we have cot half x. Okay, and 1 plus e minus x. So this should be a little challenging. Okay. So I'm going to again draw pi over 2 and pi. Okay. Typically, I have the graph of tan x. Tan x looks something like this. But you see the graph has been through a transformation that says half x. If you remember, every x coordinate now has to be multiplied with 2, which means that the graph of tan half x would have looked something like this. It would have an asymptote at this. Okay, so my asymptotes have also shifted. So I'm going to say that let's just first draw an asymptote. Okay, and let's draw the graph of tan x first. Okay, so if this was the graph of tan x, the graph of cot x would look something like this. Okay, this is cot half x. Then I have 1 plus e power minus x. First, I need to find out what my y-intercept is. So that comes out as 2. This is going to mark 2 here. Okay. Now, where is my graph going? It's minus x, so it needs to come down somewhere. Okay. Typically, it has an asymptote at 0. But now that asymptote should also have moved, and it should have moved to 1 because this graph has been transformed to 1. In a simple idea, what I would tell you is that instead of trying to worry about all of that, why don't you just calculate e power minus pi and see what your endpoint is. I know that my shape has to be correct, so I'll make sure that I draw the shape correctly. Minus pi. Okay, that gives me 0.956. So I'm just going to draw something like this. Okay, so that's the graph of 1 plus e power minus x. I know that minus x is down like that. Okay. Since my video is flipped, you're seeing my hands moving in the opposite direction. This is modulus. I think everybody understands modulus. You draw the graph of 2x minus 3 and minus 2x plus 3, and then see. Then look for a v. Okay. Okay, then this is a similar graph for 4 minus x squared sec half x. I'm going to draw this for you. Um, so 0 to 90 again, pi over 2 and pi now. Okay, so cos x used to look something like this, where it would have stretched, so it would look like that, and then go down. So sec half x should look with an asymptote at pi. It should look something like this. Okay, so that is sec half x. You think about cos half x first and then transform it to sec half x. The real challenge here is to, what I should do is I should move this the graph down so that I can draw the axis properly. Okay, I've taken a bit of a large axis, but again, 4 minus x squared. I should know where my turning point is. Like I found out the turning point, this also looks similar. The turning point is at 0, comma 4. Okay, now a lot of people are confused about where the other point has to be drawn. I know that this graph has to look something like this, right? Okay, and the best way out is to just take the x coordinate, that's pi, so 4 minus pi squared gives me minus 5.86, minus 5.87. So my graph will go down here. I wish I had drawn a smaller axis. Since I've drawn it very large, I'm going to shrink it, and my graph will look something like this. My graph will go down from here, and let's say minus 1, 2, 3, 4, and 5. Okay. So my graph will look something like this. Should it be with a solid line? Okay. It can come and intersect this axis because it's technically intersecting as well. And on the other hand as well, it's going to look something like this. But I don't need to draw that. I need to draw it from 0 to pi. Okay. Let's look at the last one. This is unusual. It says x power 5. Now, you've never seen a graph for x power 5. Do you know what the graph of x cube looks like? It looks like this. The graphs of just x cube, x power 5, x power 7. So x power 5 will also look like this. It's just going to be steeper that way. Okay. So x power 5 will be steeper. It doesn't matter, steep or flat doesn't matter as long as you draw the shape correctly. X power 7 would be even higher. X power 1 becomes a straight line. So that's different. Okay. So x power 3, x power 5, all of these look like this. Okay. And then when you're trying to drop 2 plus x, what you're going to do is you're going to calculate the intercepts and say that 2 plus x will look something like this. Okay, and it's going to have one root. Okay, that's the graph of x power 5, and this red one is the graph of x power 5 and x cubed. Okay. Okay, that's it about graphs for today. What someone was asking me is that there could be unusual graphs as well. So for example, the graph of y equals to root x looks something like this. Then the idea simply is that you should know that um, you should know the correct shape of the graph. It's not important to have every point labeled correctly, but as long as you have the correct shape of the graph, what you can then go ahead and say is that you can transform, you can use x-intercepts and y-intercepts. Remember that the examiner grades you on one, the correct shape of the graph, and one correct intercepts if there are any. So if you draw the wrong intercept, you might lose a mark. So make sure that you calculate your x and y intercepts correctly. If there are any other questions, please make sure to drop your question in the comments and I will be glad to answer them. Thank you for watching.